Just confirm if my screen is visible. Is it?
Yes,
Yes,
sir.
sir.
Yeah, okay. So today's topic is your introduction to forecasting. I think I have covered this a bit in your first class. Philosophy of forecasting, forecasting process, and some methods of forecasting. Okay. So it's your unit 1 and part 2. Okay. If you see your syllabus. So forecasting, if you go with the forecasting techniques, I think you might have studied some kind of forecasting in some of your subjects related with your data science or maybe the business analytics. Okay. So coming to these types of forecasting, in I think if I can remember, there is one subject called marketing. I think so. In marketing, people usually study this qualitative and quantitative forecasting techniques because sometimes they have to forecast the sales, maybe for marketing and all. So you might have studied, I think, I'm just assuming it in marketing paper. So coming to this qualitative and quantitative. So if you go with the quantitative forecasting methods, the first one is time series and second one is your associative models. So time series is also, I think, in coming classes, we will study in detail the time series machine learning models and also the associative models, which are in your, I think, in unit 2. So we will cover it, the associative models as well as the time series. Time series model is in, I think, unit 3 or maybe in unit 4. So coming to this qualitative methods of forecasting, usually we have many, but for example, the important one is let's say the Delphi methods, the sales for, you can say whenever you want to forecast some sales. So sales forecasting methods. Then coming to your market survey, we call it sometime marketing research, maybe we call it a market research sometime. Then coming to this executive opinion. So these are the some you can say the qualitative techniques where we have some elements of judgment. Okay. If you see how you are judging it. Okay. So our opinion are involved in this, but in quantitative, more of a, you can say, the quantifiable numbers of maybe the biasness are involved, but you can still identify the amount of, you can say, the biasness, the amount of error, at least in quantity methods of forecasting. Okay. But in qualitative methods, it's more of a judgment, you can say. Our personal biases are there which cannot be quantified. Okay. So these techniques, qualitative, are sometimes more critical, but when your data are not in terms of numbers, then how you are going to forecast it? So these are the some methods, the qualitative methods, which can help you predict something, which can still help you forecast some sales for your company. Okay. So that is why these qualitative methods are more important. But quantitative, in that case, because the numbers are, you have the historical data with you, you have everything with you. Only you have to apply some ML models. Maybe if your data had some time element, then you can apply the time series model. If the time component is not there, you just want some kind of correlation or regression, then you can go with this associative models. So coming to this larger picture of these forecasting methods, I already told you in qualitative methods we are more biasness is more involved, and more of a judgmental methods. We are judging it through our past experiences. Okay. But in quantity methods, as I already told you, this causal and econometrics. So you might have studied in maybe in MBA. There is a one more paper called econometrics. So in that, most of your you can say the ML models involved this correlation and regression kind of a thing, and also the time series methods. So casual methods, I also teach you in this unit 2, the causation and you can say the regression, or you can say the correlation part. Okay, so time series, there are different methods of you can say the time series methods or models. For example, there is something called past average, and that is also a naive approach. Then moving average, weighted moving average, and exponential smoothing. Okay, so these are the some methods, the time series methods, which involve some kind of averaging. They are just averaging it out to give you the forecasting. Okay, so as some elements of time components are involved in all these four, you can say the forecasting techniques. Okay, so is my screen visible now?
Yes,
Yes,
sir.
sir.
Okay,
Yes,
if you have any question you can ask in between, because I can't see you all. Okay, so you can ask in between. Okay, so these are the some you can say the four time series methods. So now coming to some quantitative and qualitative methods, we will see one by one. So first we will see the quantitative methods. So the first approach is your naive approach. Okay, so sometimes your naive is something, I mean we can relate with the naive person, right? So we will use this naive approach for forecasting, right? For example, if January sales were, let's say, for XYZ company is 68, the number of sales they were able to close was 68. Then February, they might predict that in February also they will have the similar number of the sales. So these are the some naive approach, because you are not able to find any patterns. Even if you have some historical data or anything, you are just going with this traditional approach, that is your naive approach, because it's cost effective and easy to forecast, but it's not a good approach. But you have to start from somewhere. That is why you go with this naive approach. Okay, so coming to this second method, that is your moving average. Okay, so moving average, if you see any time series models, they use this kind of you can say the algorithms, the moving average, in their algorithms to predict. Okay, in coming classes you will see how different time series model, let's say ARIMA, ARIMA, SARIMA, there are some models, LSTM. If you see their in their backbone, you can say they use this kind of some averages, the moving average you can say, to predict, because there are some element of time that is involved in that. Okay, so coming to this moving average, as we are saying, they use this arithmetic means. So in machine learning algorithms, if you see whichever you have studied, they do have their more focus is on this mean, or you can say the average. Okay, so if there is a no trend, or you can say if you see your data in Excel sheet, and if you are not able to find any patterns, or you struggle with no trend in the data, then you try to go with this moving average. Okay, so I'll show you one example how you can calculate this moving average. Let's say demand in previous n periods and divided by n. Okay, that is the formula of moving average. So just see this one. Let's say You have a retail outlet, okay, and you are selling, let's say, some equipments, okay. So in January you were able to sell, let's say, 10, February 12 and 13, and goes on, right, up to December. This is, let's say, in 2021, okay. So now you want to forecast for next year in April, okay, because for moving average at least you must have 3 months data, right, to predict for this fourth month, fifth, sixth, seventh, at least you have a 3 months data to predict the moving average, okay. Just see. So coming to this moving average methods, just see 10, 12 and 13. 10, 12 and 13, they are adding up. This is averaging and divided by 3. So 11 point, let's say 2 by 3. So let's say 11.1 or something, or we can say only 11. So next year the forecast for April 20, let's say April 2022 would be 11. So number of sales that can happen in April 2022 is 11. Similarly 13, 16 if you go, and so on, right? So for moving average you must have data of previous 3 months, and then you just do average it out, okay. So it will give you a moving average. If you want to select 4-month moving average, then at least you have a 4 month of a data. You can go with the 5th month or 6th month, okay, depending on the nature of store that you operate, the kind of you can say the customers you attract, that is the basis for the moving average you want to apply, okay. Then you will apply in that way. But typically most of the company apply moving average like this, okay. 3-month moving average, maybe the 5th, 4 months, 6 month, something like that, okay. These are the basis of some forecasting techniques, okay, and these are the some time series forecasting techniques. And then coming to this weighted moving average, where you just assign a weight. Just see the weight, we are multiplying the demand by the weights, okay. So moving average and weighted moving average has one difference. In weighted moving average we are just multiplying the weight, okay, and also whatever weights was we are multiplying, we are just dividing it, the weights, summing of all the weights, okay. So if you have a little trend in your data, okay, if you find some trend in the data, then you go with this weighted moving average, okay. And then remember, if you multiply moving average with some weights, you end up calculating this weighted moving average, okay. So just see the same example, how you will apply this weighted moving averages, okay. So weighted moving averages, just see, so we have a year data, sales data, let's say, and now you want to apply the weighted moving average, okay. So for weighted moving average, just see, they are also applying 3-month weighted moving average here. The difference between this weighted and moving average is just a component of weights. We are assigning the weights, but it's for example, you can assign as per your convenience, but typically we have some you can say the way of assigning is just let's say the 10th is the sales happening in the first month, we are multiplying by 1. 12th, the number of sales which is happening in second month, and 13 number of sales which is happening in third month. So these are the weights, and these are the, you can say, the actual sales happening, and actual sales multiplied by weights will give you the weighted moving average, and we are just dividing it by 2 plus 3 plus 1, that is 6. It is the sum of the weights. So the actual sales divided by the weights, actual sales divided by multiplying by the weights, actual sales and multiplying by the weights. So these are the some way of calculating the weighted moving average. Okay. So 12 is the forecast for, let's say, next year, which will happen in April. Okay. Similarly for May, the forecast is 14, then 17, 20. I'm just removing this fraction part. Okay. So these are the some way which can give you the forecast, and the moving average and weighted moving average. So because as weighted moving average has some patterns, so moving average and weighted moving average, the weighted moving average will give you more, you can say, the accurate results. It will close to the some, you can say, the predicted forecasting methods. If you go with the actual minus predicted sales, the error will be minimized in weighted moving average. So if in your exams, if someone asks you, so just remember it, just you have to multiply by the weights. Weight is nothing but the month. Let's say you are starting with 1, 2 and 3, multiply by 3, 2 and 1. Similarly for 16, 13 and 12, just remove 10 and 12, 13 and 16. This is like this. So 16 will come first, then 13 and then 12. Okay, just remember it. Just remove 1 because we have to calculate 3-month weighted moving average. Okay, so this is how you can calculate it. So for the formula, as you can see, third is the last, you can say, the last month sale, and maybe it's in January, February, March. So it's March and then February and then let's say January. Okay, and divided by sum of the weights. This is just a formula, a small formula. So weighted moving average has some weight associated with it. That is why it makes more, you can say, accurate, not you can say so accurate, but much better than the moving average methods. Okay, because there are some weights attached with it. Okay, so weight is something which is just removing the biasness, removing your, you can say, the minimizing the error, and going with the actual prediction, close to the actual prediction. That is why weighted moving average is much better. So exponential smoothing. So exponential smoothing is, you can say, the difference of weighted moving average and exponential smoothing is that it's similar to, you can say, the weighted moving average, but there is something called alpha. So alpha is something which you have to assume it. That is kind of you can say, as per your gut feeling, you have to you can say use as per your understanding the value of alpha, but it should be in between 0 to 1. You cannot take 100%, and also you cannot take this the 0. Okay, because it is very subjective. Okay, so just see how it is different from weighted moving average. So if you go with this formula, ultimately we have to forecast it. Okay, so new forecast is nothing but you are just forecasting for, let's say, a new month, let's say coming month you want to forecast. So whatever sales happened, or you can say whatever was our last forecast, last month's forecast, we will take last month's forecast plus alpha of last month forecast, you can say the demand, minus last period's forecast. Okay, actual demand minus predicted demand. Okay, so predicted is nothing but it's a forecast. Actual demand, whatever was the actual, let's say 12 was the actual demand, but you just forecasted 9. Okay, so you have to add the last period forecast. Okay, the you can say the predicted one, last period, plus alpha of actual minus last period forecast. Okay, actual minus predicted, and you will multiply by alpha. And as I already said, you have to take alpha in between 0 to 1. Okay, so smoothing is very important and it is very subjective, and your answer may vary. Okay, because someone can select, let's say, 0.5 and someone has selected 0.2. Okay, so because as per your convenience you will select, so obviously your new forecast, the new, you can say, the forecast for month will vary. Okay, so let's say predicted demand, let's say you have predicted demand for, let's say, April was 142 uh, Mustangs, right? And actual demand was, let's say, 153, but you have predicted 142. Okay, so and the constant which you selected, the alpha one, is 0.20. Okay, you may select 0.50, maybe 0.10. Okay, so if you select it, so the actual demand minus predicted one. Okay, and you have to multiply by, let's say, whatever you have assumed the alpha. This will give you the new forecast. Okay, so whatever you have calculated, let's say, so it is giving you 144 cars, the new forecast, the forecast for new month. Okay, so if you select 0.3, it may vary up to 144 only. So the decimal point, whatever you are selecting, will not create much problem. Okay, so the new forecast, let's say, your predicted demand was 142, but actual you sold was 153 cars. Okay, your demand was, let's say, whatever you predicted was 142, but the actually you sold was 153. Okay, and now you are forecasting for new month, now it is 144. Okay, so exponential smoothing is something which is just, you can say, uh, extension of, you can say, the weighted moving average. Okay, so this will give you a kind of a forecasting which will help you understand how time series methods actually works. Okay, so let's say there are some models called ARIMA, SARIMA, right, LSTM. So they do nothing, but their, the back end works like this. Okay, so coming to this quantity methods, the forecasting methods, the the econometrics methods, you can say. So they use, uh, if you go with this correlation part, that there were two, you can say, the associative models. One was correlation and other was regression. Okay, and correlation and regression I will cover it in your coming classes, because that is in your unit 2. So coming to this correlation, I think you all people might be knowing what is correlation. Okay, so can anybody tell me what is correlation? What is correlation? Ariv, are you there?
So finding the similarities or relationship between two variables.
Similarity.
The relationship basically, the how they interconnect or
Okay, okay. You are partially right. Okay, anybody else who want to define, because definition is there on your slide. Okay, so okay, so coming to this correlation part, it's nothing but, you can say, the strength of association. How, let's say, one variable and this is second variable, how they are connected, how they are associated. This is the strength of association. Let's say I'm moving this car to 1 unit, so how far this car will go. Okay, so the linear relationship, you can say, not non-linear relationship. In correlation, let's say I move this car to 1 unit, this car may go up to 0.5 unit, may go, let's say 0.75 unit. Okay, so the linear relationship we are seeing, if we are increasing this, it may increase or it may decrease, but in linear means in one direction. Non-linear may be like this. Okay, so as it is written here, the strength of relationship between the relative movements of two variables. If I am moving this car will also move. So these are the two variables. So whenever you see correlation, just remember it, they are talking about the two variable. One variable like this, and this is second variable. Okay, so co means two, and the relation, the relationship between the two variables, how strong that relationship can be calculated using this correlation coefficient. So whenever you try to calculate the correlation coefficient, it will let you know how strong two variables are, means how two variables are associated with each other. Okay, so sometimes their values, the correlation values will range from -1 to 1. 1 means the two variables are highly correlated. For example, BTech EC students and BTech, let's say, electrical students, there some subjects are related. Okay, if you ask these two students, they will give you similar results. So these two batch of students, you will find they are highly correlated. Okay, maybe BTech IT and BTech CSC, okay, they are highly correlated. Okay, but when you compare BTech IT with BTech biotechnology student, you may find some kind of a low correlation. Okay, maybe if you compare with BTech IT with MBA students, there might be fluctuation of correlation. Okay, so how two variables are associated and their linear relationship, just remember it, linear is the word which is very important between the two variables. Okay, so this will give you some kind of clue that if let's say, for example, if temperature rises, you start sweating. Okay, so the reason for, let's say, sweating may be some other factors. So correlation never tells you the causation. It doesn't mean that the temperature is rising, due to that you are sweating. That may be some other problem, maybe the BP problem or other problems that is creating you to sweat more, right? So the intervention of third variable, I'll teach you in correlation and causation, that correlation is not always causation. Okay, so there is something called no correlation, highly, you can say the high correlation, or negative correlation. For example, if you are increasing the GDP, your, let's say, unemployment will decrease. Okay, so these are negatively correlated. Okay, so you will find it in your you can say some business applications, the correlation part. And correlation is the basis of linear regression, you can say. The basic funda of this linear regression lies in this correlation and causation, because if you people might have worked on multiple linear regression problems, if you have, let's say, 10 to 12 variables, there might be a chance of some variables may be the highly correlated. For example, the square feet, let's say, if you are capturing the dimension of any buildings and the dimension of any rooms, the flat, if you are capturing it in square feet and also you are capturing in a square meter, So if you compare and if you correlate it, they will be highly correlated because they are pointing to the same thing. Okay. So in that case, highly correlated variables, we just pick up one and remove others. Okay. So that is why correlation play an important role whenever you formulate any multiple linear regression ML models. Okay. Because if you have a 10 variables, you just try to reduce the dimensions. The one way of reducing dimension is the correlation part. You just check correlations, and those variables which are highly correlated, you just try to pick one, so that you cannot disturb the entire, you can say, the entire philosophy behind the ML models. You just remove one variable, okay, out of highly correlated one. So coming to this regression part, the basis of regression lies in correlation, as I already said. So can anybody define what is regression? Regression, just try. What is regression? I think you might have studied regression. Anybody can define what is regression? Okay, coming to this regression part, let's see. Regression is nothing but we have some independent variable, okay, and then you have a dependent variable. So if your sales is increasing, your revenue will increase also. Okay, let's say sales is independent variable and your revenue is dependent variable. Okay, so this is the example of simple linear regression. So independent variable is x here and dependent variable is y. And now we are plotting. Let's say sales was, let's say, 20 number of sales and your revenue was, let's say, $400, let's say. Similarly, your 30 units of, you can say, sales, your revenue maybe goes up to $600. Similarly, for, let's say, 40 sales, and now we have $800, the revenue you have now. Okay, so this is how we are just plotting in a regression. We are just trying to see the dependency of one variable, how your sales is depending on revenue. Okay, so x is your independent variable and y is dependent variable. So how they are related? Regression tells you how independent variable is depending on dependent variable. So how we are just trying to, I mean, it's just you are trying to capture the mathematical way how they are related, how x and y are related. So whenever you run any regression problem, they will give you some coefficients. So coefficient is nothing but it gives you some relationship between dependent and independent variable, which you can easily quantify. Okay, that is your regression problem. Okay, and let's say if you have a many, let's say, feature is nothing but the different axis, but your dependent variable will be, let's say, in the y-axis. For example, you have a sales, maybe the marketing budget, maybe different cost. If you have 3-4, let's say, variables, that will come under multiple linear regression. We have a, let's say, more than 2 variables which are independent. Okay, and based on that you are trying to predict the sales. Okay, so that will come under multiple linear regression. Regression have a different types: simple linear, multiple linear, Riesz regression, lasso regression, maybe the polynomial regression. There are many regression. Okay, so, and now coming to our last part, that is our qualitative methods. As I already told you, in qualitative methods of forecasting, it's more of a judgment based. We put our judgment in it. So our personal biases are involved when we try to predict, you can say, in qualitative way. Okay, because the way we think, whatever experience we have, based on that we are trying to forecast it. As our qualitative method cannot be quantified it, We cannot quantify it, because if we have some numbers, we can easily say this much is the error involved while predicting it, while forecasting it. But when it comes to the qualitative methods, we don't have any quantifiable numbers which we can attach while you can say forecasting. So judgment is, obviously we have some personal biases, so the judgment will create more problem for forecasting. That is why these methods sometimes doesn't work. But as we don't have any quantifiable numbers, we have to take help of qualitative methods. And in social, you can say the social research, majority of the research based on the qualitative methods. Okay. For example, what your voters think of, let's say, present government. So what are the different, you can say the grievances of the common people of US for the present government. Okay, so that can be captured using some surveys, and majority of the people might have filled up some surveys in your lifetime. Okay, so the qualitative methods have some biases, but at least they give you some patterns. Okay, now let's see this one. So before I come up to this qualitative methods, I'm just telling you how you develop a new product first. Okay, so we typically go with this idea generation, then we try to screen out our ideas. If you have, let's say, 4 or 5 ideas, we come up with 1 or 2 concrete ideas. We may work for 1 ideas, then we just try to check our concept, or that is proof of concept sometimes we call it. Then around that concept proof, once we are able to do that, we go with this marketing strategy. So strategy is more important, okay, because it is linked with how you are trying to roll out your product in the market. So a strategy is, you can say, the backbone of any company or maybe any product. So what is your strategy, by the way? Okay, if you are developing, let's say, any AI enabled systems, okay, let's say if you are building any AI systems for the blind people, what will be your marketing strategy? Obviously you want to roll in the market, whether your target audience is let's say or Indian or foreigners. Okay, and then you go with this business analysis that how many customers I have to acquire, let's say, and what will be the price of the product. Okay, so some analysis also require your marketing, and that we call it a sometimes the strategy part. Okay, so once you develop this product, once you, let's say, AI enabled systems for virtually, you can say, visually impaired people is developed, you just go and checking for the test marketing. Okay, you just give it to some people, few people, that is your test marketing. I'll let you know what is test marketing here also. Okay, and then you go with this commercialization. You might have studied in maybe in technology transfer or maybe in technology management. Okay, so once your product is developed, you try to go with this commercialization of the product, patent filing. Okay, then you try to commercialize it, and then you sell it in the market. Okay, so these are the some way, you can say, for new product development. Okay, so how the qualitative method will help you forecast, and then you can build some strategy out of that. Okay, just see. The first qualitative method is your you can say the expert opinion, or sometimes you call it a opinion survey. And also we know sometime opinion matters. For example, if you want opinion of people that to whom they want to vote for, in 2025 election in US, let's say. Okay, so the opinion survey, there are many, you can say, uh, broadcasting company, you may the news channels, they rely on opinion survey. In India, there are many, you can say, the opinion survey are typically done before any elections. Okay, maybe the CNN, they do ABP News, maybe sometime uh, TS channel, I don't know, the Chanakya survey, I can recall it, some C voters. Okay, they do take help of this opinion survey. So sometime they go with the experts. You might have seen the panel of experts on the TV news. Okay, they give the views. Okay, but here we are talking about in terms of our you can sales and marketing. Okay, so for example, if someone in the sales industry have, let's say, 25 years of experience, so we typically go with their thought process, because they have seen the market, how market behaved in last 20-25 years. Okay, so we go with their views, we take their views and try to forecast it. So maybe in the expert view, we take help of, let's say, 4 5 or whatever number of experts available, we take their opinion. Okay, so the opinion survey is something which can give you some contrary result, some contradictory result. Okay, because one expert may say, let's say, the sales may happen, let's say, if it's a huge industry, okay, they may say, okay, you will able to do, let's say, 100 such sales in a month. Second one may say 50 or 80. So it may vary, the opinion may vary. Okay, but at least if you have 4 5 let's say experts, you can at least average it out their forecast, and still you will have some numbers in opinion survey. Okay, so that is good in some way, but not the best approach. Okay, so coming to this market survey, the second one. So the market survey is, you can say, nothing. Sometimes you call it a marketing research or market research. Okay, so as it is saying, it includes social and opinion research, and it's a systematic way of gathering and interpretation of information about individual or organization using statistical and analytical methods and techniques of the applied social sciences to gain insights. It's very important. Just try to find some patterns in the data, and then you take some decisions. Okay, so every company has some decision support systems which are integrated with this market research. Okay, so how market research can help you out in forecasting? So there are different methods of this market research also. In qualitative methods of market research, we have some, let's say, focus group. Sometimes we take some depth interviews, and there is something called ethnography. Okay, so most of the the social science researchers use this ethnography, where it's very difficult to take an interview of some people which you cannot even access it. Okay, for example, some nomadic people, you just want to know their cultures, their history, so you go with this ethnography, and there are some more you can say the research that is involved. Sometimes you have to disguise yourself and take informations. Okay, so the focus group, if you go with this focus group, there are a team of some people, let's say 4 5, and you just pose questions to them, and they give their insights. Sometimes you do one-to-one interview, that is the depth interview. Okay, let's say if you want to know the result of, let's say, COVID pandemic, you just want the idea, or you can say how people felt during this COVID-19. Okay, so you go on, let's say, if you have selected let's say 100 people with different demography, different age, you go one by one and take the depth interview, and then you analyze it. That is your depth interview. That will come under qualitative way. Okay. This is also market research. Okay. And a way of forecasting something. Okay. Now coming to this, you can say the Delphi methods. Okay. Coming to this Delphi methods, I think you might have studied this in marketing paper. Okay. So these all methods, forecasting methods in your marketing papers. So in Delphi method, let's say you have a different expert panels. Okay. Here, let's say 10 or 12, you just give questionnaire to every single people. You just invite them and you have given it separately. And you keep anonymity. Okay. Once they have filled in, so this will come, the filled in papers will come to questionnaires will come to the moderators, and moderator will analyze it. Okay. If there is some problem, they can go with the different, you can say, the expert panel. And if there is a need of some reformulation, because if there is no consensus or maybe some conflicts in some questionnaire or maybe in some questions, so in that case we try to reformulate it. Again, you just distribute it to expert panel and then you evaluate it. Only moderator can see, individual can't see what they have filled in. Okay, so this is some, you can say, the Delphi methods. Okay, and this Delphi methods is very much important. Okay, because at least this methods can give you a better result than other two previous methods. But market research, at least you can say, the much better methods, because that involve this, you can say, the quantitative methods also, because when you fill any surveys, that will come under the quantity methods. Okay, because survey is gonna give you some graphs, charts that can tell you a bigger story. Okay, so expert can, in Delphi methods, can go to 100 people, let's say, and you can go with the 2-3 rounds if there is some problem. Okay, so in Delphi methods, because as the number of people increases, okay, you can capture the broader vision of the expert panel, so that the chances of biasness can be reduced, the chances of error. So that is why in forecasting methods, majority of the company, you can say, at some point they go with this Delphi methods for forecasting, because somehow they are able to minimize the biasness. Okay, so that is why Delphi method is also one of the effective methods for forecasting. Okay, so coming to the last method, this last method is your test marketing. Okay, so I think I'm just assuming you people might have heard of this test marketing. So for example, test marketing, a limited launch of product to test its marketing program and the reaction of potential customer, that is more important. We are trying to capture the reaction in a real world setting. Okay, so that is more in, for example, if you are selling out some, let's say, AI devices, okay, and you are trying to just test it in an open market, let's say, and now you are trying to capture there also how they happy, how they satisfied, they look satisfied when they operate the AI enabled system, let's say. So in test marketing, the beauty of this test marketing is that you are able to capture the reaction of the potential customers, and also it takes time, because it's not like a one day. You have to go with the different people with different demography, with different, you can say, their educational background, different income sectors, just to test it out, that what is their reactions. Because once you have some feedback, you keep on working and keep on modifying your product before launching it in the market. Okay. So test marketing is obviously the costly because it involves more people. Okay. So now coming to this different types of this test marketing. The first one is a standard test marketing. So in a standard test marketing, we just try to select few cities. Okay. So as you have studied in marketing, maybe there is something called segmentation, targeting, positioning. Okay. You're just trying to segment it out based on, let's say, the demography. Okay. So, and then you roll out the product just to test it out. What is the reaction of the people? Okay. And their performance is measured through some, you just conduct some survey with the distributors, consumers, and whosoever in the store. Okay. We take their feedback about the product. Okay. So, and we choose, you can say, one city as the population. Okay. And the sample would be obviously the customers, the people of that city. Okay. So this will help us measure the performance of the product, you can say. And once we have this performance measures and we are able to capture the potential customers, so test marketing will help us. If there is need of modifying our product and services, we will just modify it. Okay. Yeah, second method is controlled test market. Obviously, as it is saying controlled test market, so we will use some kind of, you can say, the control environment where you can control at least. Okay. So for example, you might have seen some limited time new menu items in XYZ, let's say, restaurant. So if some restaurant launched new food items, let's say, or maybe the new drinks, so they just roll out in some outlet and they try to capture the reaction of the people. Let's say if it is their taste is good or not, and their price, let's say, their packaging. Okay, everything that can be captured in a controlled manner. Okay, so that is why you just take help of this controlled test market. Okay, and then comes this simulated test market. Okay, so simulation is nothing but you can say a virtual, or you can say the replication of real world in a virtual way. That is called a simulation. You are just simulating the real world. Okay, so you might have seen some virtual stores, maybe you might have seen in YouTube, Instagram, maybe then Facebook. Whenever XYZ company or product based company, they just try to test a new product, they just simulate the product, their features, or maybe their stores. Okay, to give a real shopping experience. That will come under simulated test marketing conditions. So as social media is growing, as the virtual world is somehow translating into real world, simulated test market are helping people attract, and somehow it's a good way of capturing the potential, you can say, customers. Okay, so simulation and the simulated environment to roll out any product and to test before full-fledged rollout in the market is a good way. Okay, and also you can capture the potential, you can say, the customers. You can also predict the potential sales could happen. Okay, so that is why this is one of the new and the finest way of forecasting methods, and it also help at some time. Okay, so this is all from my side. If you have any questions, you can ask. Okay.